Hello students, I am Dr. Shekhar. Welcome to Dental Pulse Academy. Today I'll be teaching you community dentistry. This subject is actually one of the most difficult and yet very scoring subject. Community dentistry has an edge in a way that community dentistry needs some logical explanation, and if you understand that logical explanation, no question will be found difficult. To start with, community dentistry has a variety of topics. The most important ones are biostats, epidemiology, public health, and preventive dentistry. Today, we are going to start with biostatistics. So, biostatistics. Let's start with the introduction to biostatistics. How many people know actually the meaning of biostatistics? It is a term made by two words, bios and statistics. Bios and statistics. Bios means health and statistics is a study of numbers. So in total biostatistics becomes study of numbers related to health. Well, the father of statistics was Sir Ronald Fisher, and his pupil Sir Francis Galton was the first one to apply statistics to biology, called as father of biostatistics. Few books do mention Sir John Grant as father of biostatistics. That is also not wrong. John Grant was neither a mathematician, neither an epidemiologist, but still he is considered by some authors as father of biostatistics. So both Sir Francis Galton and Sir John Grant are considered as father of biostatistics. Now, what does biostatistics do? Biostatistics has a basic purpose of converting data into relevant information. What does this word mean? Relevant information. Relevant information means any information that we need to apply to the population for health research. So it shows the achievements or the failures of any type of research that we do. Statistics actually has an application in any health field. When in public health, it is called as health statistics. In medicine, it is called as medical statistics, and in population-related studies, it is called as vital statistics. So any health field requires application of biostatistics. In order to understand biostatistics, we need to first learn a few basic terminologies, and that is very important. The first terminology that we need to know is population. What is a population? Population is actually the statistical aggregate. That means the total number of people that we need to focus upon. Any research that we do, we will be applying the outcome of that research to the population. So by definition, it is a group of individuals on which research will be applicable. Research you're going to do may be in a smaller number, but its outcome will be applicable to the entire population. The next term is sample. Sample means a fraction, a subset, the statistical fraction which is a subset of the population. Sample is that part of population on which the study will be actually conducted. If you are able to conduct the study on the entire population, that is very good, because you will be getting the outcome of the entire population. But if not possible on the entire population, we need to have a representative sample from the population. Next term is parameters. What is a parameter? Parameter is that characteristic that you are actually going to study in the population or in the sample. For example, I want to study height of males in any class. So height is the parameter and male is the population. The next and the most important term in biostatistics is data. What do you mean by this word data? Data means information. Any kind of information, be it height, be it weight, be it any kind of health related information that you collect is termed as data. Data is a plural word and its singular is datum. That means one information. So one information is datum and a collection of information, multiple information is called as data. So collection of data is actually collection of information. Data can be in any form. For example, there were 100 students. The height of the person is 6 feet. The weight of the person is 70 kg. Cancer was on the first stage. There can be any sort of information. Next term is variable. Variable is anything that varies. For example, number of students, blood pressure, weight, DMFT score, everything that varies from person to person. That is called as a variable. So basically, what are we going to learn here is that the data that is recorded is actually recorded under a variable. For example, gender. Gender is a variable and the data recorded under that variable gender is male and female. So any data is actually recorded under a variable. Variable is anything that varies and the data is the information that is being collected from the variable. Next we come to types of data. We have two types of data, qualitative and quantitative. Qualitative has two subparts, nominal and ordinal. Quantitative has two subparts, discrete and continuous, or we also call it as interval and ratio. So what is qualitative data? Qualitative data, as the name suggests, is the type of information that is recorded as per quality or as per category. The information which is measured in categories and describes the quality of the parameter such as gender, religion, location, nationality, blood group, all those things which cannot be actually measured but just can only be placed under a category. Again, I am repeating it. It cannot be measured but can only be placed under a category. For example, pain. If I describe pain as mild, moderate and severe, I cannot measure how much is mild pain, how much is moderate pain, how much is severe pain. But these are categories in which a person can be assigned. So these are categories recorded as a categorical data called as qualitative data. Qualitative data has two subparts, nominal and ordinal. Both of them are categories. The simple difference is ordinal means categories are placed in an order and nominal means categories are not placed in an order. For example, blood group. Blood group has four subtypes A, B, AB and O. There is no order in this. There is nothing less or more than the other. So this is kind of nominal data. Similarly, gender. Male, female. States of India. Any state is the same as the other state. They are all states of India. But in ordinal, there is always an order. For example, years of BDS. First year, second year, third year, fourth year, internship. Similarly, ranks in army. Lieutenant, colonel, lieutenant colonel and so on. So any data. Similarly, if you consider pain, mild, moderate, severe pain. So any data which is considered as an qualitative data which is recorded as categories and placed in an order is called as ordinal data. If not placed in order, it is a nominal data. The other form is quantitative data. As the name suggests, the data which is expressed in quantity, in a magnitude. Anything that has a magnitude and has a quantity is a quantitative data. It can be of two types, discrete and continuous. The only difference is that discrete means whole numbers and continuous may have decimals. Whole numbers. For example, there are 10 students in this class. They cannot be 10.5. I have 2 siblings. They cannot be 2.5. This house has 5 doors. Cannot be 5.5. So anything that can express only in a whole number is called as a discrete data. But yes, it has a magnitude. The other form is continuous data. Continuous data is the type of data which may have decimals. For example, weight. Weight can be 70 kg, 70.1 kg, 70.11 kg, 70.111 kg. Any form of decibel is called as continuous data. The basic difference is that discrete only has whole numbers and continuous may have decimals. However, the continuous data is always placed on a scale. For example, weight. Weight has 70, 71, 72, 73 kgs based on a per kilogram scale, and it may have decimals in between the continuous data. If we go back to the flow chart, we will see that there was another form of quantitative data, interval and ratio, under the discrete and continuous data. Now, what is interval data? Interval data is the data which is placed on the scale at equal intervals. It may be discrete, it may be continuous. If the scale has decimals, the interval is actually a continuous data. If the scale does not have decimals, the interval data will be a discrete data. And the ratio data is actually the comparison of two continuous data. Now, there is an exception which is called as the Likert scale. Likert scale is a 3-point or a 5-point or a 7-point scale. Likert scale is mostly used as an expression of the respondent as to how does he like the intervention. Good, bad, okay, very good, very bad, in that ways. But Likert scale is actually scored as a discrete data, as a quantitative data. So the Likert scale is an exception that it is demonstrated as a qualitative data, but it is calculated as a quantitative data. One thing I want to focus you all upon is that data can be converted from quantitative to qualitative, but not from qualitative to quantitative. For example, if I have 5 people having high BP and the BP level is 120, 131, 140, 149 and 160. This data can be categorized into low BP such as 120 to, which is a category having 120 to 139, moderate BP which has a category of 140 to 159 and severe BP which has more than 160 millimeter of mercury. Now this transition from quantitative data to qualitative data, now here we have absolute numbers and here we have categories. No matter how much the BP patient has, with whatever BP the patient has, it will fall into low BP if it comes under this category. So in this way, the quantitative data can be expressed into three categories. That is a conversion from quantitative to qualitative. Next term that we need to know is variable. As I told you initially, that variable is something that varies and data is recorded under the variable. So variable is of two types, qualitative data and quantitative data. So the variable that measures qualitative data is a qualitative variable and the variable that measures quantitative data is a quantitative variable. Simple. However, there is another classification of variable which is independent and dependent. Now, what is independent and what is dependent variable? Imagine a case situation. For example, smoking causes lung cancer. Now in this case, existence of lung cancer is dependent on smoking, whether the patient is smoking or not. Existence of dental caries is dependent on whether the patient consumes excessive sugar or not. So in this case, lung cancer becomes the dependent and smoking becomes the independent. Independent variable is the independent factor that is acting upon the dependent variable. So basically, independent variable is the intervention or the risk factor and dependent variable is the outcome, which is the result of action from the independent variable. Next is collection of data. How do we collect data? Data is collected by primary sources and secondary sources. Primary data is the first-hand information. That means the data the person collects themselves. If I want to do a study, I go to the population and I collect the study and I collect the measurements myself. It is a primary source of data. And secondary source of data is utilizing an already recorded data. That means if there is any report or any census or any record available on the internet or from any other library, any other online library, if I utilize that, but I utilize it for a new purpose, new objective, I cannot repeat the objective, I cannot repeat the purpose. If I utilize the existing data for a new purpose, that is called as a secondary source of data. Method of collection of data. How do we collect data? It is of three types: method of direct observation, method of house-to-house visit, and method of mailed questionnaire. Simple. Direct observation is when you go meet the person directly, take the measurements, take the interview, take the intervention, give the intervention. That is a method of collection of data. Second is method of house-to-house visit, also called as surveys. It is the most common method employed by the Government of India during census. We record vital statistics and surveys through this. In the method of mailed questionnaire, it can reach to multiple respondents at once. The major advantage is that we can save time, but the disadvantage is that it has to be given to persons whose literacy is very high. Next is presentation of data. How do we present data? All the data that is collected through various sources under various variables, that is parameters, all the data that is collected needs to be presented. It will be presented either by text, tables or graphs. That is the only way. Number one is text. Text is just a textual information or data written in sentences, in paragraphs. It, however, is not recommended because no one can actually comprehend what is coming out of a paragraph. The purpose of presentation of data is that the data needs to be presented in such a way that the reader is able to easily comprehend, easily understand what the author is trying to say. Next is the table. We have certain parts of the table: the heading, the body, the box head and the stubs. And we also have certain footnotes. Table is a good format. Table is a very good format when we present a data, and we usually present a data both in table as well as graphical form. However, there is a different category of table called as a frequency distribution table, which may display the data in a class interval. Class interval means small ranges. For example, when you have age groups 0 to 10 years, 11 to 20 years, 21 to 30 years. So that class interval when is there, we consider it as a frequency distribution table. The third method of presentation of data is by graphs. Now graphs can be qualitative or quantitative. Qualitative graphs which show qualitative data, quantitative graphs which show quantitative data. The types of qualitative graphs we have is the simple bar, multiple bar, component bar, proportional bar, pie chart, pictogram and cartogram. First we'll do the qualitative graphs. Number one is the simple bar diagram. Now I'm sure everybody must have seen this diagram, a simple bar diagram. Here we see bars of various sizes depicting the data. Now this figure which you are seeing is actually showing qualitative data and only one variable. So simple bar diagram shows qualitative data and only one qualitative variable. Next is a multiple bar. Multiple bar has multiple bars in each category. So we have qualitative data showing more than one variable. We see various bars in each category, same as the previous one. So multiple bar diagram shows qualitative data more than one variable. But there is a catch in this. Multiple bar diagram is not usually recommended to show more than 3 variables. Otherwise, the diagram will get very clumsy. The third type of diagram is the component bar diagram. If you see the difference between multiple bar and the component bar diagram, you will see that there are qualitative data being shown and more than one variable is being shown. But the difference is that in component bar, we also can see the total amount of patients in each category. Whereas in multiple bar diagram, the total is not depicted, only the distribution under each category is being depicted. So in component bar diagram, we can also see the total in each category. So anyways, when there is a requirement to show qualitative data and more than one variable, we prefer a component bar. If a question comes to you, which is the most common method to show a qualitative variable and qualitative data in more than one variable, we always prefer component bar and not multiple bar. Next is the proportional bar diagram. Now proportional bar diagram is similar to component bar diagram except for the fact that it shows data in percentages. Qualitative data, more than one variable, but in percentages. And here if you notice, all the bars are of equal height at 100%. This is the classic feature of proportional bar, that all the bars are of equal height. Differences between each category can be shown inside the bar. Next is the pie diagram. Now pie diagram shows qualitative data, one variable in percentages. That means if you have only one variable and that can be shown as a percentage distribution, it can be given in a pie diagram. Now take notice, qualitative data, one variable in percentages is pie diagram, and qualitative data, more than one variable is proportional bar. Always remember, more than one variable percentages, proportional bar, one variable in percentages is pie diagram. Pictogram is similar to simple bar diagram, but in a way that the bars are actually shown as pictures. That is the only difference. And it shows qualitative data and one variable. Next is the cartogram, or also called as spot mapping. Anything which is drawn on a map, a small map, a larger map, map of this district, map of India, map of world, anything which is drawn on a map, anything which is spotted on a map is a cartogram. As you may see in the picture, this is a classic picture which was being portrayed by John Snow, who is the father of epidemiology, which depicted cases of cholera in central London in 1880s. This is a classic picture of a cartogram which is being shown. Now we start with the quantitative graphs. First is the line diagram. Line diagram, we must have all seen that we draw lines as per the axis. The only thing that is important with the line diagram, that it is always and always plotted against time. Always and always plotted against time. One of the axes in a line diagram has to be time. If you get a question saying that this is the data measured at this much hourly interval or this much days interval, which graph is suitable against this? Always and always line diagram is plotted against time. Next quantitative graph is the histogram. Histogram is similar to the simple bar diagram in the qualitative aspect. Histogram shows the quantitative aspect. Histogram shows quantitative data in one variable. You must be noticing that here we have bars similar to bar diagram, simple bar diagram, but there are no gaps. In the simple bar diagram, we had gaps. The reason is that in a histogram, the data that we record is a continuous data, and in simple bar diagram, we record a qualitative data. So there are no gaps in the bars in the histogram. Next is the frequency polygon. Frequency polygon shows quantitative data and more than one variable. It is similar to joining multiple histograms together. So frequency polygon shows quantitative data, more than one variable. Next is the frequency distribution curve. Frequency, as we all know, is the percentage distribution, maybe of a population or any other entity. When we display it over a curve, we get a frequency distribution curve. You can see here is the bell-shaped curve, the normal curve over here. Next is the cumulative frequency curve, or it is also called as ogive. Now if you see here, there's a difference between a frequency distribution curve and a cumulative frequency distribution curve. If you want to know the difference, you must first understand what is the difference between frequency and cumulative frequency. Frequency is just the number of individuals per class, and cumulative frequency is the number of individuals every added class. For example, you see in this table, there is one person in class limit of 5 to 10, and then 3 persons in class limit of 5 to 15, and then 7 people in the class limit of 5 to 20. So as and when I go down the table, we add the number of people in every class limit. So basically I want to say that there were total of 21 people, and out of them, for example, I had 10 people which were less than 30 of class limit. So if I plot this cumulative frequency over a chart, I will get a ogive, and most of the times, almost always, ogive is always a S-shaped curve. Remember this part? Frequency distribution is mostly a bell-shaped curve and cumulative frequency is mostly a S-shaped curve. Next is the scatter diagram, and this diagram is very important as per MCQ point of view. Every student must know in detail about this diagram. In order to understand the scatter diagram, we should know how it is plotted. Let's take an example. How do we assess malnutrition among children? A quick assessment of malnutrition among children is done by 3 methods: measuring height versus age, measuring weight versus age, and measuring height versus weight. So if I ask you, how do we plot height versus age and weight versus age? The simple answer is line diagram, because age is there and it is plotted with time. So anything that is plotted with time is a line diagram. So both of these are plotted by line diagram, and height versus weight is plotted by a scatter diagram. Scatter diagram is drawn when there is a correlational relationship between the x-axis and the y-axis. That means the x and y-axis are plotted against each other, and more importantly, both the x-axis and y-axis are quantitative. If you see this diagram closely, each individual represents a dot, and that dot will correspond to its own height and weight. And when there is a bunch of people plotted on the diagram, we see a bunch of scattered dots on the graph. Now, to determine a correlationship between the x-axis and the y-axis, we see the pattern of dots that are scattered. If there is a positive correlation, the dots will be scattered in an ongoing fashion towards the up. And if there is a negative correlation, the pattern will be towards downside. And if there is no correlation, there will be no specific pattern inside the graph. Now, this correlation is actually expressed as correlation coefficient, which is denoted by R, and the value of R ranges from -1 to +1. The more the value, the higher is the correlation between x-axis and y-axis. Now, if you see that R is 1, that is perfectly positive if the dots are arranged in a exactly linear fashion, in a perfectly linear fashion. And if the dots are not arranged in a linear fashion but somewhat towards the positive side, the R value will be between 0 to +1. Same goes with 0 to -1. The dots, when they are arranged in a linear fashion towards the downside, if they are perfectly arranged in a single line, the R value will be -1. So it is important to note that the correlation will be weak near 0, that is no correlation and scattered dots, and the correlation will be strong both towards the negative and the positive side. It is a very important question that the MCQ people, the examiners, they ask that which is a stronger correlation. Do not go by the sign, -1 or +1, doesn't matter. -0.8 or +0.8 are actually both equally strongly correlated. Do not go by the sign, just by the value.